We're looking at the test 3C, practice test for AP Stats today. The first question says, a study found correlation R equals 0.61 between the sex of a worker and his or her income. You conclude that this answer is D. It's nonsense. R makes no sense here. The reason that R makes no sense is because one of the variables is the sex of the worker, which is a categorical variable, and you cannot calculate correlation when there are categorical variables. Income is a quantitative variable, so that would be okay, but if you have a categorical, you can't do correlation. They have to both be quantitative variables. Number 2, a copy machine dealer has data on the number X of copy machines at each of 89 customer locations and the number Y of service calls in a month at each location. Summary calculations give X bar is 0.84, SX is 2.1, Y bar is 14.2, SY is 3.8, and R is 0.86. What is the slope of the least squares regression line of number of service calls or number of copiers? If you want to calculate the slope, you need to use the formula, which is that B is R times SY over SX. So we're going to do 0.86 times 3.8 divided by 2.1 over on our calculator. 0.86 times 3.8 divided by 2.1 is 1.556, 1.56. Answer is B. Question 3. In the setting of the previous problem, about what percent of the variation in the number of service calls is explained by the linear relation between number of service calls and number of machines? This is one of those problems where there's nothing, they're not telling you what to do, but the code in the problem is this is the phrase for the R squared value. So if R is 0.86, you have to figure out R squared. We're going to go back to the calculator and do 0.86 squared. And that is 0.7396. So we have 74% for number 3. Question 4. If data set A of X and Y data has correlation coefficient R equals 0.65, and a second data set B has a correlation of negative 0.65, then what? Is A stronger than B? Is B stronger than A? Is neither one stronger than the other? Or you can't tell without seeing the data or the scatter plots? Or has a mistake been made because R can be negative? Well, obviously R can be negative. As it is, that just means that there's negative slope. The concept here is you don't care about the sign of the correlation, you just care about the number, the numerical value. Both of these are 0.65, so they have they're equally strong. The first one, data set A, is just in the positive direction. It's a positive slope, and B is a negative direction. It has a negative slope, but they have the same strength of correlation. Question 5. There is a linear relationship between the number of chirps made by the striped ground cricket and the air temperature. A least squares fit of some data collected by a biologist gives the model y hat equals 25.2 plus 3.3x, which is valid between x values of 9 and 25, where x is the number of chirps per minute and y hat is the estimated temperature in degrees Fahrenheit. What is the estimated increase in temperature that corresponds to an increase of 5 chirps per minute? So my first instinct, the first time I ever did this question, was to take 5 and plug it in for x. And if you do that, you will get E. But E is not the right answer. What you need to do here is figure out what is the increase in temperature if you increase the chirps by 5 per minute. So you need to pick some x value, plug it in, and then pick some different x value that's 5 units higher and plug it in and see what the difference is. So what I did is I took 10 and I plugged 10 in here, and I got that the temperature would be 58.2 degrees. And then I tried 15 and I got a temperature of 74.7, and I found the difference. The difference between there is 16.5 degrees. That's the estimated increase in temperature when you increase the chirps by 5 per minute. So B, 16.5 degrees. Question 6. Which of the following relationships is most likely to result in a strong negative correlation? So that means as the first thing increases, the second thing decreases. A, the number of people showering in a college dorm and the water pressure in each shower. If more people shower, more people use water, there's going to be less pressure for each of those showers. That's why it's A. If we just go through the others quickly, for B, the outdoor temperature and the number of fans. If the temperature goes up, you're going to use more fans, so that's not negative. C, the comfort rating of a mattress and the number of hours of sleep. If your mattress is more comfortable, you're going to get more sleep. D, the price of a home and the square footage. If the house is more expensive, it's probably larger, thus the square footage is higher. E, the fuel efficiency and the speed. As the efficiency goes up, the speed might go up, it might go down, but you're not really sure about that because there's some, I don't know how much you guys know about cars, but there's some range where as the efficiency goes up, the speed is going up, and there's other ranges where as the efficiency goes up, the speed goes down. But A is the best answer here. Number 7, a set of data relates the amount of annual salary raise and the performance rating. The least squares regression equation is y hat equals 1400 plus 2000x, where y is the raise amount and x is the performance rating. Which of statements A to D is not correct? So A says for each increase of 1 point in the performance rating, the raise will increase on average by $2,000. That's just the explanation of the slope. So that's true. B, this equation produces predicted raises with an average error of 0. This is the definition of a regression line, that the average error is 0. So any regression line, the average error is 0. So that is also a true statement. C says a rating of 0 will yield a predicted raise of 1400. If you plug in 0 for x, you get 1400 for y. So C is true. D says the correlation between salary raise and performance rating is positive. The correlation is positive because the slope is positive. So D is also true, which means that E, all of the above are true. Question 8. Leonardo da Vinci, the renowned painter, speculated that an ideal human would have an arm span, which is the distance from the outstretched fingertip of the left hand to the outstretched fingertip of the right hand, that was equal to his height. The following computer regression printout shows the results of a least squares regression on height and arm span in inches for a sample of 18 high school students. And they want to know which of the following statements is false. So, first one says this least squares regression model would make a prediction that is 1.63 inches higher than Da Vinci for a 62-inch arm span. So if we look at this information, where on earth is the actual regression equation? So the key is you need to look at this information right here. And your equation in general is y equals a plus bx. So a is your constant, and the b is your slope that's times the variable. So in this printout, when it says the constant variable, that's your a value. So 11.5474 is A, and arm span is your B variable, 0.040424. So the equation for this problem would be y equals 11.5474 plus 0.040424 x. So if we took in 62-inch arm span, that's your x variable. We want to see what the height would be. So we're going to go back over to the calculator and do 11. Actually, I'm going to make this easier. We're going to go to y equals and put this equation in. So our equation is 11.5474 plus 0.840424x. This number right here is an 8, and this is a 0, and I know it's hard to see in the video, but that's what those numbers are. So then we're going to come back to the main screen, and what we're going to do here is say vars. We want to pull up that y1 equation that we just typed in. So we go to vars and then y vars, function, and then we pick up the first one, y1. And in parentheses, we're going to plug in the x value that we have, the arm span, 62. And then hit enter. So that means the equation predicts a height of 63.6, whereas Da Vinci thinks that if you have a 62-inch arm span, your height will also be 62. So the equation is predicting 1.6 inches higher than what Da Vinci predicted. Boom, that's exactly what the A says. So that's true. B says one of the students in the sample had a height of 70.5 and an arm span of 68. The residual for this student is 1.83 inches. So the residual is based off the equation. So we need to figure out what is the predicted height of the student with an arm span of 68. So we're going to go back to our calculator, and now we're going to predict 68. I'm going to hit second enter, and that pulls up my previous equation. And I'm just going to scroll over and change 62 to 68 and hit enter. For 68, it says the prediction is 68.6. So if that is our predicted value, the actual value was 70.5. A residual is the actual minus the predicted. So we need to do 70.5 minus this answer. So we're going to say 70.5 minus second and the negative sign. This is the answer that we just previously had. We hit enter, we get 1.803. It's really close to this, so that is true also. D, for every 1 inch increase in arm span, the regression model predicts about a 0.84 inch increase in height. That's true. That's the definition of the slope, 0.84. E says for a student 66 inch arm span, the model would predict a height of about 67. So we got it to 66 back on the calculator. We're going to hit vars, y vars, enter, enter, y1. I'm going to plug in 66 this time. And 67, so that is a true statement also, which means C has to be the false one. And C says Da Vinci's projection is lower than the prediction that this least squares line will make for any height. So if you can see from what we've looked at, if the arm span is 62, this will predict 63, and Da Vinci would have predicted 62. And this is 68.6, but he would have predicted 68. And so you can see that these projections are higher than what he would have predicted. But what if we continue increasing the height? Let's just do, a really tall person. Let's try 80. Oh, look, now it's less. He would have predicted 80 if the arm span's 80, the height's 80. But now this predicts that the height will only be 78. So sometimes the prediction is higher, and sometimes the prediction is lower, which means C is false.